Okay.
Slideshow.
Good afternoon. My name is Adelino Ferreira from Portugal. By the way, I was in Trinidad in March until 18. Then I traveled to Portugal after the problem of the COVID. I'm going to present the PAVENERGY research projects, some results already achieved and new developments for the next years. It is already a very successful project. It was financed by the Portuguese Science Foundation with almost 200,000 euros. I had also a PhD student with a scholarship. And until now, we won 11 awards, all of more than 100,000 euros in awards. From the beginning of the project was 2016, and it ends in July this year. These are the tasks of the project. You can see later, if you want, in the site of the project, more details about this. I'm going to pass to some results. We developed a first prototype that we insert in the university campus for people. It was called Way Energy People. It is a system to generate electrical energy by the movement of people, in this case, by the weight of the people passing over the system. In this figure, we can see a person with 75 kilograms and different values for the electrical energy generated by a soft walk, a normal walk, hard walk, and jump. And we published this in a Journal of the Web of Science in 2000, before the project. Then we developed a second prototype, this one for vehicles. It was called Way Energy Vehicles, also for generating electrical energy with different speed of the vehicles. I show here a graph with the energy generated for different speeds, 10 kilometers per hour, 20, 30, 40, and 50. This kind of system is to insert in urban areas, and in Portugal, for example, the maximum speed is 15 kilometers per hour. And with that system, this prototype, we published 2 papers. Then it was another task of the project. We need to develop a software tool for simulating the vehicle-road interaction. For what? For discover the best characteristics of the system without build them. We can simulate lots of different characteristics and choose the best one to build, to apply in a road later. This software was also published in the Engineering Computation Journal. And I show here some part of the software. Later, we have the opportunity to apply a real-world application in a shopping mall in Lisbon, Portugal, for people with 25 modules of the Way Energy People that you can see in this figure. And in the right, we can see the electrical energy generated during 1 hour. It was an application in collaboration with the owner of the shopping malls called Continent in Portugal. It's the top company that has shopping malls all over the country, and also in other countries, in Brazil and others. Later, last year, 2019, we applied the energy vehicles in a city in Portugal, in Coimbra, with 10 modules. Each road passes in 5 of the modules, in the right and in the left. And in the graph, you can see the energy during 1 day. Now we are in 2020. We are developing a third prototype, more efficient. For example, we have 100 modules inserted into the pavement consecutively, like we can see in this picture, 100 of this type of system. It can be used to substitute speed humps and speed bumps that are inserted into pavements to reduce the speed of the traffic. And we can use this and at the same time generate electrical energy for the municipality. This is the third prototype, some pictures. This is the generator, some movements that accelerate the movement without the vertical deformation of the system. And at this moment, we are at this point, we already published, I think, 12 papers in Web of Science journals. We have more to publish. This is the site of the project, where we put everything, the awards, some pictures, the publications, the work package, members, etc., conferences. And to finish, I presented the University of Coimbra. It was established in 1290 by the King Dom Dinis of Portugal. It is World Heritage by UNESCO. It is very beautiful, the old part. To end, I have a picture of the old part. This is the King Dom Dinis. This is the palace of the king, but there are classes of law and letters in this part of the university. And the rector has also the office in the right of this place. And that's all. Thank you for the attention. I am available for questions. Thank you.
Thank you, Professor. We have some questions for you. Well, first and foremost, very interesting work, all the comments. One of the questions are, the electrical output will clearly be greatest if a resonant condition is met. How were the parameters of the energy harvester determined? That is the thickness, elasticity, etc.
In this case, it's not the bitumen. This is a system that we put, it's electrical mechanical. It works with like a piston, and it is inserted in the pavement. So this is concrete, a box concrete. The system is inside the box, and the vehicle passes over it, and there are some deformation that makes the rotation of the generator, and there are some details about to increase the rotational movement of the generator.
Okay.
It's not related to bitumen. Bitumen is outside the system.
Okay.
But there are a kind of system like this with bitumen by the temperature, but this is not the case.
Okay. Did you by chance do a life cycle analysis to account for the resources needed to build and install the devices?
We are now installing the third prototype, and we want to test it for a long time to see, for example, the maintenance of the system, the cost of maintenance. We made already a life cycle cost analysis. In 60 years, more or less, the system is paid, but without maintenance. With maintenance that we need to check, it can be more years. We don't know yet.
Okay. This question may be answered by what you said just now. They ask, how close are the prototypes to becoming a commercial product? And do you foresee any challenges to reach the commercial stage?
There are challenges. We create a startup. It is in charge, my PhD student is there in the startup. And we use the money of the awards and so on to apply the system in different situations, in cities, with the collaboration of the municipalities. Now we are going to implement in another city in the north of Portugal, more to see if there are problems of maintenance of the system for a long period of working there.
Okay. Do temperature fluctuations affect the electrical output?
The fluctuations of temperature? No.
Yeah, temperature fluctuation. No. Okay.
No, no. Because it's a mechanical. It's a mechanical system.
Okay. How does the system affect? Yes, Professor, how does the system affect the wearing properties of the pavement surface?
It can affect the skid, the resistance of the pavement. That's why we put this rubber surface over the system. This is which has similar skid resistance like as the pavement, and we choose different kinds of rubber.
Okay.
Of the asphalt mixture.
Okay. This person wanted
about
to know
skid resistance, about the road safety. It can be problems in terms of road safety. But we won some awards for road safety because the system can be used to reduce the speed of the vehicles. We can calibrate the system with more resistance or less resistance.
Okay.
And it reduces more or less speed of the vehicles without the driver braking the vehicle.
Okay. Last question, Professor. Did persons walking or driving on a device notice any difference when traversing?
I don't understand. I didn't understand.
When the persons either walked or drive on the device, did they notice any difference when traversing on it?
When the system is new,
okay,
there is no problem. There are some deformation. The deformation is higher than into the pavement. But as I said before, we can use different resistance for the system for vehicles and for people. The characteristics of the system are different.
Okay.
To support the weight of the vehicle or only a person.
Okay. You have a very interesting presentation and lots of questions. So we'll ask anybody else to contact you for following up with your research. Thank you very much, Professor.
Thank you very much.
Thank you. Thank you, Professor Ferreira. It's an excellent, interesting work, and we thoroughly enjoy it. And everyone is looking for something like that soon. Maybe it's possible that we can see this in commercial market. Okay, thank you. Appreciate your time.
Thank you.
Thank you, and stay safe. And now I'm moving to the